Hello children, Structure of the Atom, Class 9, Subject Science, Chapter 1 and this is the part 10. In the previous class we have studied about valence shell, valence electrons and valency, right? So in today's class, let us study about the types of valency. Okay, so we have got two types in valency. First one is called as electrovalency and second is covalency. Electrovalency. So let us study about the electrovalency first. So what do you mean by electrovalency? It is the valency that is attained by losing or gaining of electrons. So what do you understand by this? It is nothing but when any element, if it loses or if it gains electrons, then that types of valency is called as electrovalency. Okay, so let's take an example of sodium, and sodium's atomic number is what? 11, right? And the electronic configuration is 281. So to become stable, it either needs 7 more electrons in the KLM shell or it must lose 1 electron. Therefore, when compared to 7 electrons and 1 electrons, it is easy to lose 1 electron and become stable. Is it clear, children? Because the outermost shell should have 8 electrons to become stable, right? So, K shell has got 2 electrons, right? L shell has got 8 electrons and M shell has got 1 electron, right, as we can see in this electronic configuration. Therefore, to become stable, either it must lose 1 electron and become stable, that is 2 and 8, or it must gain 7 electrons to become stable, that is M shell will become 8 electrons. So it's very easy. So it is easy to lose 1 electron and become stable. Is it clear, children? So if an element loses electron, it becomes positive. So how can you say that when any element loses an electron, it becomes positive? See, it's very important and you must remember. See here, we know that number of protons is equals to number of electrons, right? So we already know that, see, if the sodium is having the atomic number as 11, which means number of proton is also 11 and number of electron is also 11, right? To become stable, if it loses 1 electron in the outermost shell, which means what? 11 becomes 10 and the proton remains as it is. That is, proton is nothing but 11, whereas electron becomes 10. Therefore, which is more? Proton is more. Therefore, it possesses positive charge because 1 proton is more in this case. Is it clear? So let me just read out this. If an element loses electron, it becomes positive. So in this example, it's easy to lose 1 electron and we know that number of protons is equals to number of electrons. So if it loses 1 electron, then the element becomes positive and it becomes sodium ion. Okay, so this is very, very important. If it loses electron or if it gains electron, it becomes ion. Okay. So if an element gains electron, what happens? Let's take an example of chlorine. Okay, so chlorine's atomic number is 17 and this is how the electronic configuration looks like. So in this example, what happens? Either it must lose 7 electron or it must gain 1 electron. Right? So which is easy? It's easy to gain 1 electron. Okay, so we know that proton and electron, number of protons is equals to number of electrons. And what is the atomic number? 17. Therefore, proton is also 17 and electron is also 17. So in this case, what happens? It is gaining 1 electron. Okay, so what happens? 17 becomes 18. Okay, therefore, which is more? Protons is more or electrons is more? Electron is more, right? Therefore, it carries negative charge. So if any element gains an electron, it becomes negative. Okay, and it becomes what? Chloride ion. Okay, so if any element either it gains or it loses an electron, it becomes ion. Is it clear? So let me just read out. So in this example, it's easy to gain an electron. We know that number of protons is equals to number of electrons. If it gain one electron, then the element becomes negative and it becomes chloride ion. And let's study about covalency. Okay, so this is the second type of valency. So what do you mean by covalency? See, than losing or gaining, it prefers sharing. So sharing of electrons is done in covalency. Okay, so it is the valency that is attained by sharing of electrons. Okay, it will not lose or it will not gain. It will share the electrons among two elements. Okay, so let's take an example here. So carbon atomic number is 6 and chlorine atomic number is 17. Therefore, this is how the electronic configuration looks like. So 2, 4 and here 2, 8, 7. Right. So what happens? I'll just explain to you. See, carbon. Okay. So what is the outermost shell has 4 electrons. Right. And chlorine. Chlorine has how much? 1, 2, 3, 4, 5, 6, 7 electrons. Right. In the outermost shell. So each and every side, what happens? It prefers sharing. 1, 2, 3, 4, 5, 6, 7. Okay, even here, chlorine 1, 2, 3, 4, 5, 6, 7. Here also chlorine 1, 2, 3, 4, 5, 6, 7. Okay, so what happens? Everywhere it has become stable. See here, can you see here chlorine? Okay, so here what happens? It has got 8 electrons. Here also it has got 8 electrons. Same way in every case, and even in carbon also. See, can you look here? Carbon is having 8 electrons. Everywhere it is sharing 1 electron from chlorine. So this is how the covalency works. So we have studied about the types of valency, that is electrovalency and covalency. So here are few questions. Explain electrovalency with an example. Explain covalency with an example. Na ion has completely filled K and L shells. Explain. Okay, so you know the atomic number of Na, and here we have asked about Na ion. So sodium ion means what? Either it must lose the electron or it must gain the electron. Only then it becomes ion. Okay, so you have to explain that. And fourth is write the electronic configuration of oxide ion. Oxide means what? It is oxygen ion. It is oxide ion. Okay, so you must write the electronic configuration of oxygen first, and you must see whether it is easy to gain electron or whether it is easy to lose the electron. Okay, only then it becomes the oxide ion. So you must write the electronic configuration for oxide ion. Thank you, children. Let's continue in next class.